go. Right. So this is calculus section 4.2. In this section, we're going to introduce two important theorems. Well, one important theorem, which is the mean value theorem, and one theorem which is kind of like a precursor to the mean value theorem, called Rolle's theorem. So both of these theorems have the same sort of start, which is suppose that a function is continuous and differentiable on a closed interval, a to b. Okay, technically it's only differentiable on the values strictly between a and b, not the endpoints, but whatever. So Rolle's theorem says that if f of a and f of b are equal to each other, okay, that would mean like there's 2 points that are at the same height at a and b. So I'm going to draw that like this, at a and at b. If those are equal to each other, then there will exist a number c in the interval from a to b such that f prime of c is guaranteed to equal 0. Okay. Now this all is only guaranteed because the function f is continuous and differentiable. So I'm going to draw just a random continuous differentiable function that connects these 2 points. Okay, and let's say it goes like this. All right, there's a lot of different functions I could have drawn, but whatever function you draw, as long as it's continuous, smooth, and it's a function between a and b, then you're guaranteed to find a point on that function somewhere. That's our c value, where the slope is 0, right? So this is Rolle's theorem. It's essentially saying you can't have a function that connects 2 points which are on a straight line with each other unless at some point between there and there you actually have a horizontal tangent line. That's guaranteed. Okay. So Rolle's theorem is, if you take Rolle's theorem, we're going to copy it, this picture from Rolle's theorem, copy it, and then paste it and move it over here. If you take this thing and you just skew it sideways, just skew it up or down, like for example, like that. If you do that, then you get a generalization of Rolle's theorem called the mean value theorem. So this is, by the way, a generalization, which means that basically Rolle's theorem is a special case of the mean value theorem. The mean value theorem incorporates Rolle's theorem as one case, but it is more general. Okay, it incorporates more than just Rolle's theorem, and it says it doesn't even start with an if. It just says, suppose f is a continuous differentiable function on the interval from a to b, like this here. Then there will exist a point c in that interval a to b such that the derivative of f at c is equal to the slope of the secant line between a and b, which if f of a was equal to f of b, then this difference quotient, the slope of the secant line, would be equal to 0, right? Because f of b minus f of a would be 0 if those numbers were the same number, right? Like 10 minus 10 or something like that. So, so that's how Rolle's theorem is a special case of the mean value theorem. So what we have here is we have in the mean value theorem, we have the secant line, right? And we have the tangent line here at some number c, which is inside this interval. So mean value theorem is just saying, hey, if you have 2 points on the curve of a function and you take the secant line, that slope, there's guaranteed to be a point somewhere in between where the tangent line has that same slope. Okay, and that is if the function is continuous and differentiable. So this mean value theorem is then technically we use this theorem to basically prove. This theorem proves that if f is say, increasing on an interval a to b, then that means f prime is positive on a to b, which is something we already talked about, right? This idea that like positive derivative value corresponds to increasing function. But so this mean value theorem is really like the theorem that kind of gives us the theoretical like proof, right? The real like rigorous proof of that. Now I'm not going to go through that proof, and I'm not going to go through the proofs of the Rolle's theorem or the mean value theorem, but you can check out the proofs in the textbook if you're interested. I just really want you to get the concept here, the main concept, right? Like that that if a function is has an average rate of change, that at some point on that interval, that average rate of change has to manifest as an instantaneous rate of change for a point at some point along the way. So I think that's it now for this video. So I will hit stop.